Okay, guys, power questions. Question one: what's the formula for power? And use it to give the definition of power. So, power is equal to the energy used divided by the time taken. If we think about that, that is joules, and that's seconds. So, power is a bit like the number of joules used per second. So, joules you could write that as joules per second, but we don't actually use that because the unit of power is watts. So question two was rearranged for energy and time. So energy is power times time, and time would be energy divided by power. Sometimes you can remember this power equation as the PET equation because you can say P E T. Number three, if two electric motors that lift the same weight of 80 newtons through the same height of 1.25 meters, one motor does this in 3.5 seconds, motor B does this in 2.1 seconds. Using a calculation, show that motor B is more powerful and explain why. So always start with your formula when you're working out a question. So P is equal to energy divided by time. So the power of the first motor is that it is doing, it's actually doing some work. So actually we need to think about the work done first of all, which is the same as the energy used. So work is the distance, or the force divided by the distance, so Fs. So the work done will be the force that is being lifted, so it's 85 newtons being lifted through a height of 1.25. So that is 85 times by the distance of 1.25. So that will be equal to the work done. So just so you can see this on the calculator, is giving us the work done of 106.25 joules. So that's the actual work that will be done by these motors. So the power for the first one will be the energy used, or the work done, divided by the time taken. So it was able to do the work in 3.5 seconds. The second motor did the same amount of work, but it was able to do it in 2.1 seconds. So which motor is more powerful? You should see that the second motor will be more powerful because it's able to do the same amount of work, or do the same amount of, use the same amount of energy in a shorter period of time. So 106.25 divided by 3.5 gives us 30.4 watts. And if we look at motor 2, gives us 50.6. So we can see that motor 2 is more powerful because it's able to do more, transfer more energy per unit of time. So it's more powerful. So moving on to number 4, about a dishwasher. So our dishwasher is transferring 576,000 joules of energy while switched on for 80 minutes. Calculate the power of the dishwasher. Okay, now this is an interesting question because we've been told the time in 80 minutes. So the time is 80 minutes. Now, in these calculations, when we're working with power, we always must remember to convert to seconds. So 80 times 60 is 4,800 seconds. Okay. So the power of the dishwasher, so power is the energy divided by the time taken. So the energy being used is the 576. So the energy divided by the time, which was 4,800 seconds. Giving us a power of 1200 watts. Okay, moving on to number 5. Calculate the energy transferred by a 100 watt light bulb that has been left on for 4.5 hours. So this is the time is an important factor again here, because we've been told 4.5 hours. That needs to be converted to seconds to do this calculation. So a useful tip is to remember that there are 60 seconds in a minute and 60 minutes in an hour. 60 times 60 is 3,600. So when you're doing the conversion of hours to seconds, if you multiply by 3,600, that will give you the number of seconds that is. So 16,200 seconds. We are looking at the energy transferred this time. So the energy is the power multiplied by time. So the power of our light bulb was 100 times by 16,200. So the energy will be 16. And that would be joules. So it's a big number. There's a couple of things we could do there. We could present that in standard form, or we could convert the joules into kilojoules, or we could even convert it into megajoules. So in standard form, first of all, 1.62 times 10 to the 1, 2, 3, 4, 5, 6 to the 6 joules. Or what we could say is that would be the same as 1.62 megajoules. So it's used a lot of energy because it's been left on for 4.5 hours. Moving on to question 6. We have a 3 kilowatt oven supplied with 16.2 megajoules of energy. How long is the oven switched on for? So the time, this time that we're calculating, the time is the energy divided by the power. So it is a 3 kilowatt oven, so that's the equivalent of 3,000 joules. And the sorry, wrong way around. It's been supplied with 16.2 megajoules. So 16.2 yep, divided by the power, which is 3,000. Okay, so that's our 16.2 megajoules converted into joules. So we're dividing that by 3,000. which gives us a time of 5,400 seconds. Now we could divide that then by 3,600, which would be the equivalent of 1.5 hours. Okay, moving on to question 7. So we are being told in this question that a stereo is supplied with 432 kilojoules of energy in 2 hours. Calculate the power of the stereo. So the time again, we have been told that it is 2 hours. So 2 times 3,600. So our 7,200 seconds. Like the question says, we are being asked to calculate the power of the stereo. So the power is the energy divided by the time. So the energy was 432 kilojoules. So that is 432 with 3 zeros after it to convert the kilojoules into joules, divided by the time, which was 7,200 seconds. So gives us a power of 60 watts. Question 8. An electric blanket has a power of 200 watts and it is supplied with 5.76 times 10 to the 6 joules of energy. How long is it switched on for? So the time is the energy divided by the power. So the energy used was 5.76 times 10 to the 6 joules. The power of the electric blanket was 200 watts. So it gives us the time of 28,800 seconds. If we divide that by 3,600, that would turn that number of seconds into hours, which would be 8 hours. Question 9. A student does an exercise called a chin-up. Each time the student does one chin-up, he lifts his body 0.4 meters vertically upwards. The mass of the student is 65 kilograms. The student is able to do 12 chin-ups in 60 seconds. Calculate the power developed by the student. First thing we need to think about is the work done. So the work is the force times the distance. So the work will be the force that the student is using. Now, they have a mass of 65 kilograms. So there's another formula here, W equals mg, to get us thinking about how we convert the student's mass into the force being lifted, which is the student's weight. So the weight of the student will be the 65 kilograms that he is times the gravitational field strength that we've been given of 10. So the student's weight is 650 newtons. So the work done will be 650 newtons times by the 0.4 meters that the chin-up actually is. So the 650 times 0.4 is a work done of 650 260 joules. So they did 12 chin-ups. So if we multiply that by 12, shows that they've used 3,120 joules of energy. And they did that workout in 60 seconds. So the power that they developed was the work that they did, the 3,120 divided by the 60 seconds that they did that workout for, which gives you an answer of 52 watts. Okay, that's question 1 to 9 done. Thanks for watching.